What's going on, y'all? Welcome to another learning video by Everything EE. Today we're looking at a pretty classic quiz problem. You'll see this a lot. It's finding the power that's absorbed by each element in this circuit. And so, if we take a look at our givens, we have a 20-volt voltage source. We have 3 amps coming out of it. We have this element A that has 7 volts going across it. We have element B that has 8 volts going across it, along with this voltage marking here, Vx. Oh, let's get rid of that. And then we have this uh, element C that has 5 volts going across it, along with 5 amps going through it. And then finally, we have this dependent current source that's dependent on this Vx over here. So we're using classic P equals IV for these problems, okay? So let's go ahead and get to it step by step. Let's start off with the 20-volt source. We have 20 volts and 3 amps. So P equals I times V. Our current is 3 amps, but here we have to notice that current is flowing in the opposite direction of the polarity marked, right? So if we're labeling the I going from minus to plus, we're going to have to add a negative. So the current through this source is actually going to be minus 3 amps when we're trying to find the power absorbed. So we have a minus 3 amps times 20 volts is going to be minus 60 watts. That kind of makes sense, guys, because these are sources, right? They're not going to be absorbing power. They're producing power. So minus 60 watts is kind of showing that this voltage source is actually producing power, not absorbing it like these other elements are going to. So moving along to A, we have P equals IV. We have 3 amps coming in from plus to minus, so all the signs are great. We just need a plug and chug. 3 amps times 7 volts. Okay, that's going to give us 21 watts absorbed. All right, cool. Let's move along to B. So P equals IV. What's I here? Well, we know that the current in a loop is going to be the same. So this B element is in the same loop as this 3 amps. So 3 amps is going around this entire loop. And so don't get confused here. C is part of 2 branches, right? So you have a branch over here and a branch over here. So, but it's not too confusing because we already have it clearly labeled that there's 5 amps going through C. But we'll get to that. So we have 3 amps going through B. It's going from plus to minus, so all our signs are good. It's just another plug and chug. So we got 3 amps and 8 volts. That gives us 24 watts. Okay? Let's move along to C. P equals I times V. Straightforward. We have 5 amps running from plus to minus across a 5-volt voltage across the C element. So we got 5 amps times 5 volts gives us 25 watts. Cool? All right. Let's move over to this dependent current source. So let's check these things out, right? So first things first, right? We need to figure out what this Vx is. So what is Vx, right? Oh, at first glance you're gonna be like, oh, Vx is 8 volts, but that would be wrong. That's not right. we have to pay attention to the polarity markings that's in this givens labeling. So we have a plus here, a minus here, and a minus here, and a plus here. So Vx is actually showing that it's the opposite polarity of this, what's marked 8 volts. So we're going to have to add a negative there. So Vx is minus 8 volts. Volts, not watts. Ugh. Volts. Let's see if we get it this time. Alright, so let's go ahead and work that out then. What is the current here in this dependent source that I'm going to call ID? ID is going to be minus 0.25 times Vx, which is minus 8 volts. Okay, so that's going to give us 2 amps. Now, we can sort of sanity check ourselves that this makes sense because of KCL, Kirchhoff's current law, which states that a current going into a node is equal to the currents going out of a node, right? So we know that there's 3 amps going out right here. So it makes sense that what we have left, 5 minus 3 is 2. It makes sense that what we have left is 2 amps going out here. Okay? So that's going to be our current. Now, what's our voltage, right? So C, element C and the dependent current source, they're in parallel. So they share the same voltage. So we can see here we have 5 volts. So that's the same. So we have plus minus 5 volts across this current source. But which direction is the current going? It's going from minus to plus on this 5 volts. So we have to add a negative here. So we have, well, not here. We'll do it down here. So P equals I times V. Our I is going to be a minus 2 amps because it's going in the opposite direction of the polarity markings. It's going from minus to plus instead of plus to minus. So we put a minus there, and we put 5 volts for the voltage. That's going to give us 10 minus 10 watts. Okay? Sweet. So that's all we got here. We found the power absorbed by all of these sources and elements, and you'll notice here something neat here. Since we have sources are negative, they're sort of supplying power. We have minus 60 here. We have minus 10 here. That gives us minus 70. And if you check out the elements, you'll see 21 plus 24 plus 25. That's going to give you 70. So everything balances out. So it kind of just makes sense there as a sanity check. So like always, guys, post your comments, questions. Let us know if you have any problems you would like some help on, and we'll definitely look into it. Don't forget to like and subscribe. Y'all have a great day.